to Mobile Dev for Web Devs. I'm Justin James. I'm a DevOps evangelist, web developer, and Microsoft MVP. Mobile represents the single largest technology innovation of all time. 10x faster than the PC boom, 2x faster than the internet boom, and 3x faster than the social networking explosion. Those are some gigantic numbers. I wanted to join that revolution too. So I thought, I'll build a mobile app. Actually, I built a mobile game called Touch My Monkey. This is why we don't let developers name apps. It's a Simon Says game. You get some circles with some monkey faces on them. It plays it in order like Simon Says does, and you have to click through it just like Simon Says. We used a traditional development strategy for this. That meant we had full access to the device, all the power that the device happened to have. We had high flexibility per device. It also meant we had a code base per device. It meant we needed to learn multiple technologies. Objective-C at the time we built it, because Swift didn't exist. If we wanted Android, we needed to have Java and Kotlin. And that was because Objective-C and Swift is what you need for iOS, and Java is what you need for Android. Two code bases, a lot of times that means two teams. It's really difficult to be an expert on both languages. So we kind of know, hopefully, what the issue is with multiple teams and all that funness. But it gets even bigger when you start looking outside the mobile space. We looked at iOS and Android, but now we have web. If you want to do a desktop app for Mac, you need to know Swift. If in different paradigms than the mobile, you want to do a desktop app on Windows, .NET Universal. To be an expert, we've only got 5 technologies. We haven't even touched IoT devices, TVs, all those other things that we have now. That's hard to be an expert in every single one of those. And it's expensive for a business to hire a team to be an expert. And inevitably, first version, it all matches. And that's the only version that's going to match feature for feature ever. Because you're going to have multiple teams. When we built my app, this is how we felt the whole time. Everyone on my team, including myself, we were web developers. This Objective-C stuff, none of it made sense to us. What do you mean we have to do memory management? Like, we came from a .NET stack, and none of us had done C++ or C. We didn't have to do any kind of memory management. It did it all for us. We knew at some point in time, it was all going to come crashing down. I can't believe people actually drive around this thing. This is a real road somewhere. And there's people walking around it too. I'm like, you guys are nuts. So that was around 2010. I swore I'm never again doing a mobile app. I hated it, every bit of it. Well, fast forward, right around 2014, I took a road trip from Phoenix, where I'm from, out to LA for their code camp. At the time, their code camp website had a horrible, horrible mobile interface. Take their website, shrink it down, don't increase any of the fonts, so all the fonts were like 4-point fonts. Another presenter was showing me a new version he was working on. It looked super professional, had all the hamburger menus that you would expect, readable grids, master details. I was like, how long did this take you? He said, 48 hours. Well, what'd you build it in? A whole bunch of web stuff. I was like, ooh, I'm intrigued. I can maybe build actually some mobile stuff without having to learn a whole bunch of new skills that I'm only going to use on side projects. That's where I learned about hybrid mobile development. This time, we get all the device integration with one code base. Our downside, we have a little bit of constrained performance, because it's obviously going to be some web technologies and not native. But 80–90% of apps out there, they're line of business kind of apps. You've got some forms, you've got some data, you got some grids. Those are absolutely perfect. You're not trying to get 60 frames per second trying to do a game. For those, maybe you do look at the native piece. But for those other 80–90%, hybrid. And that means HTML5, CSS3, JavaScript, now TypeScript. Now instead of having just 2 platforms, all of this opens up. We can do mobile, traditional web apps, desktop apps, IoT, server-side, TV apps, proprietary devices like consoles, all using the same technologies. Now you can do it with one team. You can create one code base, deploy everywhere. So see if you can spot the web app here. You've got Untapped, Uber, Sworkit, VS Code, Slack. All of those are actually built with web technologies. It's pretty amazing when you play with those apps. I use VS Code every single day. If you didn't know it was a web app already, you wouldn't be able to tell. It performs extremely well for being web-based. I would love to say Slack performs extremely well, but you get enough Slack channels in there and it doesn't perform as well. But for one Slack channel, it performs amazing. I think I've got 10 in my Slack app, and it still performs decent. It's not terrible. And it's essentially same app, different experience. We've got, what, 6, 7 apps on here, 7 device types. Everything from watches, phones, tablets, desktop, console apps, same app. But we want to skin it differently. Our traditional use case, got 7 of them. Actually, 8 of them. Obviously, my math is bad today. So we've got mobile, iOS and Android. We've got web, desktop, mobile. We now have PWAs. We have regular desktop apps as well. Windows, Mac, Linux. We do it all one code base. So let's solve the mobile first. We'll look at desktop apps, and we'll look at the web apps in a bit. So what do we want to achieve here? One code base, all using web technologies. We want it to run the same way across all of the platforms. Sometimes you see people go, oh, one code base. Well, that just means I have a bunch of if statements that say, if Android do this, if iOS do this. That's not what we're looking for. We want to have just the code that we need to make the functionality, and it behind the scenes does all the work without us having to code it up. We still need access, though, to some of the hardware. Bluetooth, GPS, battery, network, flashlights. We have to be able to do that in a mobile application. And just like our code, we want to access it in the same way. We don't want to have all this customized stuff just to access hardware. Thankfully enough, every modern device can run these web technologies now. No longer is it the days of just being a toy. If you look at the specs of the new iPhone, I'm sure some of us still have computers at home that don't have the same specs. I know I've got older computers that run slower than some of these iPhones. You have a full computer in your pocket. You can run all this stuff at full speed. And web developers are everywhere. Everyone thinks they can do a website, which means they know some bit of HTML, they know some bit of CSS, some bit of JavaScript and TypeScript. They can now do mobile applications with their limited skills that they even have. You can find them everywhere. So what are we going to use to do cross-platform development? Because we've got to have some way to get it on the devices. That's where Cordova comes in. Apache Cordova is an open source middleware piece that really just takes your web code, bundles it up in what's needed to actually install on the device, and then it's the middleware layer to give you that access into the device itself, the Bluetooth, the GPSs. And it's strictly middleware, no UI. So let's look at our stack here a little bit. So we start with our code. Because there's no UI stack, we have to, in Cordova, program the UI stack. We have to figure out how do we get it to change per device? How do we get it to look like it belongs in Android and iOS and the web? And all of that runs on our mobile devices in a web view, which really is the browser engine behind the scenes. Get rid of the title bars, get rid of all the different status bars, take just the engine, and that's what it runs inside of. And then that sits inside of that native container that it bundles it up into. And then we have our Cordova piece that talks between the web view and the native container for all of the device access, the Bluetooth and the GPSs. Pretty simple stack. We don't have to do anything other than write our code at this point. The Cordova will do all the rest of that integration for us. To get started with it, we need Node, because that's where their command line tools are. I like to use the LTS versions of Node. Right now they're at 6. At least I think it's still 6. 8's supposed to be coming out soon. Then we have one npm package to install globally that would get us the Cordova command line. It's npm install -g Cordova. We'll be up and running, but only to do testing on the web. So to get it on the device, you still have to install some additional stuff, lots of stuff. Thankfully, Android works across all of the devices, or all the platforms, Windows, Linux, Mac. You need the Java SDK, so 8's the latest version. You need the Android SDK. That's how you're going to play and get on the actual device. Gradle, nothing more than used to actually orchestrate the build. Google Chrome you'll want so you can actually do debugging on the device. Just like you can hook up the debugger typically for web projects with the dev tools, they have a way that you can inspect an Android device that's hooked up through USB. You want the emulator if you don't happen to have an Android device. The really cool part is even with the emulator, you can still do that Chrome debugging. And the last piece you need is a Google Developers account in order to get in the Play Store. You don't have to buy the account until you're ready to actually do a production release of it. And you only have to buy it once, and it's $25. It's a lifetime account. So pretty cheap. It works across all your apps. It's not $25 per app. It's $25 for however many apps you happen to release. iOS, there's a similar setup with one major constraint. You have to have iOS to even do any of the stuff that we're going to talk about. That's an Apple requirement, nothing more. Cordova works on all the platforms, so it's strictly Apple. And it's because you need Xcode to do all the compilations, and Xcode is a Mac-only application. You want the Xcode command line tools as well. Just like we have a Google emulator, they call it iOS Simulator. Same concept. Safari is the same exact concept as Google Chrome for Android. You can do the same kind of debugging. Here's where there's a little difference in the accounts. It's $99 for the account, and it's a yearly $99. And if you don't renew it, all of your apps that you have in the App Store will drop out after some point in time from the App Store and not be available any longer. Hence, if you go find Touch My Monkey or try to find it, it's not there because we quit renewing our account. So, mobile problem solved, right? Sounds decent. Well, not quite. So mobile platforms do have some different behaviors. They have different UI SDKs. I already mentioned Cordova doesn't have an UI library in it, so you have to use something else. Our user experience is different across every one. If you just use Cordova by itself, you got to do all of that programming. You go, oh, I'm only this size of a device. Let me resize my UI and do that responsive UI. Nobody wants to really program that up. No one wants to figure out, oh, the icon for a phone looks different on Android versus iOS. No one wants to write that level of code. But you have to do that at this point. Some devices also have back buttons. Some do not. We also have tablets. It's not just phones. We want to be able to reuse our code as we've talked about. One code base. So let's look at how visually everything we've kind of talked about really works. So in the native app, we've got all the animations, tabs, buttons, all the stuff that we can get access to. It talks to all the devices. On the Cordova side, we have Cordova, a web view, and our HTML code that does so a lot more constraints. But how do we achieve this unified experience? That's where the Ionic framework comes in. All of this stuff where I've been talking about, you've got to code all this stuff up by hand, they do that work for you. It'll change around your icons, change around the looks and feels. We'll see that in the demo, that just simple stuff like some of the colors. We'll look at a grid and see, in a master detail grid, iOS has a right arrow. Android does not have a right arrow. Ionic now takes care of all of that work for you. I remember when Ionic first came out in version 1, I'm not an Android user, and I had no clue till version 2 came out that Android doesn't have the right arrow button, because it was always there. They're about 95% parity between making the changes for you. you were. Before you had to make about those last 10%, they're getting better and better. So you don't have to write all that custom code. And it really is our missing UI framework. It supports iOS, Android, Windows Universal as well. Well, not Windows Phone. Windows Universal is the desktop portion. They technically supported Windows Phone, but as we all know, that product has been dead for a while, and Microsoft officially announced that this last week. Ionic's also open source, at least for the framework piece. We'll see it a little bit later. They have some non-open source stuff. Obviously, they have to be able to make some bit of money in order to survive as a company. But from the framework side, the UI side, all the important stuff in order to get the app working, that's all open source. They build all their stuff with web technologies. Today, it's built on top of Angular. They're using TypeScript, HTML. They actually use Sass, which is a form of CSS. They're really performance obsessed as well. They want the apps to perform as fast as possible. They don't want you to go, oh, not another one of these apps that's web-based. They want you to not even know. And their goal is zero code redundancy. That one code base. That used to be the myth. Everyone always preached that, oh, we can get one code base. And they always had those if statements and all that other craziness. So it really never was one. Theirs is one. You don't have all those if statements. They take care of that for you, and that's their goal. Let you focus on your app and your business logic and not on the framework side of it. So our stack, very similar to Cordova. We start with our code. This time we have a UI library, which is Ionic, and Ionic sits on top of Angular, at least today. We'll see later on why I say just today. But I was happy as an Angular developer that this is where they based it. They didn't come up with another MVC framework, because God knows we have enough web-based MVC frameworks. So they built it on top of something that was already known. And we still have the web view, we still have our native container, and we still have the Cordova pieces. Just look at a few features. So I've talked a bit about they adjust the platform accordingly. And we'll see a bigger version of this screenshot where there's 3 different platforms here. You can just see in the top header, the middle one looks pretty different than the ones on the left and the right. There's no code changes here for that little piece. They took care of that because in Android, that is what it is supposed to look like. They also have a tremendous icon library. There's over 900 icons that they have. So they try to look at all the icons that are on the platforms, give you a web-based version of that, and give you one that works for all of the platforms. So it's not just, oh, here's the phone icon. It's like, no, here's the phone one for Windows. Here's the phone one for Android, phone one for iOS. Because, of course, all the vendors have to have their own custom icons. You want your users to realize this belongs on Android or iOS. You don't want them to go, I know it's a phone, but is this really the phone? You don't want them to question that. With the latest version of Ionic, you can also customize the heck out of all of these components. You can turn off certain features. If you really wanted your iOS app to look like the Android or vice versa, you can actually go down and configure that and turn off some of the specific platform features if you wanted to. They have all kinds of customization. They have all kinds of components. Here, all the standard stuff, tabs, menus, cards, grids, modals, pop-ups, all of them out of the box. Their docs are absolutely amazing for these. You can go in the docs, copy and paste out their samples, and they're all working samples. I've created full kitchen sink demo apps just copying and pasting out of the docs and setting up routing. And they also have examples in the docs as you're scrolling through. They have a little phone-looking icon where you can see what would it look like in iOS, Android. I'm assuming the Windows one is gone. But you can play with them, interact with them right there, and as you scroll through their docs, it updates each one of the samples was in there to keep playing with. And all of them are on Plunker, so you could go and play a lot more with Plunker, and it's pretty amazing. They also have a fantastic CLI tool. It takes care of all the scaffolding for you. So they've got blank template, they've got a side menu, a tab, creates all the stuff you need to get your app running and serves it out. Has all the Sass pre-processing and compilation, all the TypeScript compilations. It's got some error reporting baked into it. And it also does the code bundling and the AOT tree shaking stuff so that you can get the smallest bundle. Even though all this code is going to ship down to the actual device, you still don't want to have a humongous bundle. The browser engine still has to process it. So smaller you can get that bundle, the better, especially in the NPM world. There's so many modules in the node modules folder, you don't want to bundle up 300,000 files if you only need 3 or 4 of them. So it does all that tree shaking to figure out what you're using and only bundles those pieces. They also support right to left, internationalization. They have Ionic Native, which is their plugin system to go through Cordova to get access to the device. And they give you a standard API that enables promises. It also enables observables. Every one of their plugins, they have about 70 to 80 plugins. They all work the same way with that common API. If you ever go to the Cordova plugin registry, you'll notice there's several hundred versus Ionic's 80. Ionic was really nice and said, we only need one of each one. I don't need 20 different flashlight plugins. I just need one. I'm going to pick the one I think is the best, and we're going to go that route. Because that's what is happening in the Cordova plugin registry. There's 20 flashlights, 30 GPS ones. Everyone thinks they have a better way to do it. The Ionic guys picked one, so you don't have to worry about making that decision. So this all sounds great. Hopefully some people are using it, which they are. Through their command line tool, they've had 4 million apps generated so far. They have 110 plus countries that actually have communities. These are meetup groups or user groups that meet regularly. They have an extremely busy Slack channel, 13,000 members. It's the only Slack that I'm part of that I fully turn off notifications. And I turn off the Slack icon that says, you have unread messages, because it's always unread. Like, I'm one of those people that doesn't like to have the unread, so I have to turn that off. But it's a great place to get immediate help. There's people all over the world. The Ionic team's in there as well, typically, so you can get help immediately. They've got over 30,000 stars on GitHub. Some major companies have picked up on Ionic. Microsoft, Airbus, Dow Jones. There's even some cool apps that have come out recently. Untap and Sworkit have been there for a while. Microsoft Flow, which just recently came out, it's Ionic based. So some big companies have picked it up. Installation-wise, it's going to be very similar to Cordova. We start with Node, and instead of installing npm-install-g Cordova, we do Ionic instead, and you'll get your command line tools. Project creation-wise, we do Ionic start, give it an application name, and then one of 3 templates. Blank just scaffolds you out a project that's ready for you to put all of your code in. There's no example pages, no route setup. It's just a little baseline container. Tabs, that's what we saw on the slide earlier, where it has the buttons at the bottom of the page. Gives you that layout with some sample pages. Side menu gives you the hamburger menu. All wired up with some pages, so you can play around with them. Once you get your project generated, you got 2 ways to serve it out. Ionic Serve will open up Chrome, and by default it launches an Android-looking version. You can open up the Chrome DevTools and change it. Ionic Lab is a really cool feature where you can put multiple platforms in there. You can put iOS and Android in there at the same time and see what are they going to look like. You can play with both on the same screen. Ultimately, you're going to want to deploy on a platform. You've got to add the platform. Ionic Platform Add, either Android or iOS. It'll download everything it needs in order to do the bundling. Because nothing says you have to be on Android or have to be on iOS. You could pick both. You could pick one or the other. Then to test on the device, Ionic Run. If you're using an emulator, you say emulate. If you're using a device that's hooked up through USB, you say run. In either Android or iOS, it'll go through, do all the compilation, create everything it needs to deploy to the device, and deploy the actual application to the device for you to start playing with. Pretty simple to get started. So let's take a look at a little bit of code here. Any questions while I'm pulling this up? So let's run our Ionic Lab here. And this one is Ionic Start tabs. So we'll see what our tab menu looks like. We can see it's going through doing all of our compilations here. It's cleaning our previous build. It's doing all our transpilations, setting up Webpack, setting up all of our SAS compilations. Let's see. Let's refresh this thing. There we go. One more time. It is caching big time. I gotta love that. Okay, so the app on that side of the screen is what it's supposed to look like. The app on the right, we'll look at it in a bit. We can see we've already got all of our tabs down here at the bottom. We've got some pages wired up. You can click through, see everything. And this piece, actually, let's take off this platform. See if I re-add it. Nope. So let's take a look at real quick at code for how do they do the contact page and how do they do the tabs. So those tabs are pretty simple to do. They have an Ion tabs control built in as one of the components. You say Ion tabs, give it a tab, tell it where's it going to go, what do I want the title to be, and what do I want my icon to be. It takes care of the rest of that UI for you. It's going to resize everything, make it the right height, make your icon centered, make your text look right, so you don't have to write any of that CSS. There's no CSS that I've written behind those tabs. Same thing for the content page. So it's technically a grid. It's hard to tell on the Android platform. It's way easier to tell on iOS because you can click on the link and go somewhere, so it has the right arrow button. This is an Ion list, is what gives you the grid. You give it a little header so you have a title on it. Then each row is an item. And you just tell it, what do you actually want in there for text? Do I want icons? Do I want just plain text? Do I want to click on it? And it does all the formatting. And we'll see that in a second. I'm going to start up the side menu one because there's actually a better demo in the side menu. And since lab's given issues, we're going to run just Ionic serve, and we will see it start up in Chrome here. So the tab one doesn't have many pages. They're not well filled out in the template, but they're already wired up for you. We'll see in the side menu here, it's actually wired up quite a bit better. There you go. So you can see we've got a nice side menu going on here. I can click on them. I can go to different places. And let's look at and we're going to pop this down and go or iOS. And refresh. There we go. So now we can see, got a few differences. We can see our right arrow that I said would show up. We can see grid lines. We can see highlighting. That wasn't there when we looked at the Android one. They do all of that kind of stuff for you. So you get to focus on business logic. Stop that. Let's look at a real application here. Actually, you know what? This is the real app since it's caching hardcore. So we can click through all of these pieces, see our master detail. We can see our back buttons that show up. What's really cool here is the back buttons adjust as well. So if you're an Android user, you know it's a different looking arrow. You know there's no back text actually there. You also know that your header is left aligned, not center aligned on Android. If I pick, we'll try that device. So we'll see that here. We can see our right arrow went away. We can see different back button, different header here at the top. No code differences. Just pretty darn amazing. So that solves our mobile problem. Well, let's solve the web problem. What if I actually wanted to use desktop web or mobile web? It really comes down to adapting to screen size. We've got tablets, big monitors, laptops. We've got different input devices. Now we're talking keyboard and mouse, not just touch. We also need to start worrying about accessibility. People have screen readers on desktops. We've got to worry about those things. So this is going to be a quick demo. If I close down our DevTools, here's our web version. Same code. Built into Ionic, they have a control called split pane. So it will take your menu, always show the menu, and then show all of your content into the centerpiece, and you can interact with it exactly the same way. Okay, I can do mouse, I can do touch screen still. All of that works. No code differences. That's the easiest demo ever. So we solved the web problem. Kind of, sort of. But what about PWAs? Those are kind of the new hotness. That's our progressive web apps. Basically a web app that works offline. And you can install it on your mobile device. It'll come with the full screen like in real app and an icon and all that. And it works thanks to our manifest JSON and a service worker file, which come out of the box actually in the Ionic application, or in the Ionic templates. Before we get there, let's look at our state of our offline. So right now, we've done some amazing things in tech. Teslas have ludicrous mode in their cars. We've invented some AI stuff. We have self-driving cars now based off AI. We've got reusable rockets that can land again on a launch pad. Who would have ever thought? But we get this awesome dinosaur game when you play offline. If you don't know, if you open up Chrome when you're offline, you can actually play the dinosaur game. So it's great on airplanes when you have no Wi-Fi. But what about service workers? What do they actually do? Nothing more than proxying between your app and your server. And they can cache an unlimited amount of data on the device. So typically, a lot of PWAs and service workers will cache what was the last thing that you actually looked at and have that available offline for you. And because you can cache unlimited amounts, you could cache a good majority of stuff. Like I know the Angular docs are actually working on making a full PWA for their docs offline to be able to view all of their docs and all of their samples. So it's not just the page you're on, it's everything. It also solves what people like to call the Li-Fi problem. Those times where your phone swears you have 2 bars, and you absolutely know you have 0 because nothing's coming up. I walk into half these conference rooms, and it swears I have service, and it goes absolutely nowhere. That's the Li-Fi. If you were doing PWA, you would still be able to look up whatever it is you need to look up. I wish the conference schedules would do that, so I can stop having to save the PDF file somewhere. So let's look at how do we enable service workers. Let's go back to our conference. Actually, we'll look at a different one of these apps. Let's look at the side menu. So if I go into here and I pull up my index file, I will see a tad bit of code down here that is commented out. So it's already got the script to enable the service worker. And if I look at my actual files here, I can see I have my manifest file and I have my service worker file, all out of the box, which means now I can fully support offline. I could turn off my Wi-Fi right now. It would still show you the same amount of data that you saw before. Didn't have to do anything more than uncomment something. And obviously, you're going to want to fill out your manifest file because there's some stuff in here like, what is your actual logo? So if you update your logo PNG to be your real actual icon you want, it'll be correct. Service workers is all about what are you actually going to cache? So you can set it up to cache only certain pages. You can set it up to cache everything. But you have to set that piece up because they don't presume what you want to cache. And heck, if you wanted to cache a Google map, I'm sure you could cache the response from the HTML back from that and still display it offline. It's just up to you to figure out. And that's all there is to our PWA story. Pretty simple story. So web solved. Let's look at desktop. Let's solve that one. So there's a lot in common with web as far as user experience. People are a little more forgiving, though, about user experience on the desktop, but it's getting less and less that way. We're getting nicer looking desktop apps, and people are starting to expect certain bits of usability and user experience. Offline, absolute must. If you opened up Word or Excel or any other Office program on your laptop, you expect that to work, even if you have no Wi-Fi at all. That's just an expectation users have always had because it's always worked that way. It has to support all the platforms, and all the platforms have different looking UI skins. And we want to be able to reuse between each platform. That's where Electron comes in. That's what Visual Studio Code and Slack sits on. That's the underlying framework that enables them to bundle all of that web code up. Really, think of it as Cordova for your desktop. It's open source, just like everything else we've kind of talked about. You use all the web technologies to code up your app. So to get all your navigation menus, your right-click or left-click menu, right-click menus, all of that's built into Electron, and you code it up using JavaScript. And it supports all of our platforms. So we've seen two apps that most of us probably use every day. So let's look at the Electron piece here. Make sure I stop all of these. Stopped. Good. So Electron-wise, on GitHub, let's zoom this in a tad bit. Under the Electron repo, they have an Electron Quick Start. That's what I'm going to actually use for my container. And when you scroll down to the how to use, it's basically clone it, cd into it, run npm install, and then run npm start to get it working. One difference I changed with it, I went into the main.js file, and I updated my path to say, go to my Ionic index HTML file so I can use the conference app that we were looking at a bit ago inside of a desktop app. So now if I run npm start, wait for this thing to quickly compile, I now have a full desktop app with the same code base that we've been looking at this whole time. And I get all my menus put in. It's pretty darn cool that I didn't have to do anything, and that just works. And literally, I saw someone do this at a conference recently. I thought, oh, I got to add that to my talk. I thought it's going to take a while. Literally, I was 5 minutes to make all of this work. It took longer to do cloning and npm install than it did to actually make the thing work. So desktop, solved, same code base. So now we've got 8 different platforms that we've looked at, same code base. I didn't make a single coding change between any of those. And I didn't code anything up specifically for those inside of the demos. So a few other things to be aware of. So I mentioned today it's baked on top of Angular. Well, there's something they've recently announced called Stencil JS. This is a compiler for generating native web components. It's going to power Ionic 4, because right now we're at Ionic 3. And this means they become framework agnostic. No longer are their components going to be tied to just Angular. You'll be able to use them in React and any other framework that you want to be able to use it in, because it'll be based off of the standard native web components that are available to us to write. And you can actually play with this today. On their GitHub, so github.com/ionic-team, they have a stencil repo where you can play around with what they are doing today. So it's only been a few weeks since they've announced that they're even doing stuff with stencil. But it's pretty exciting. It's the one place where a lot of people said for years, I really want to use this, but we're a React shop. Okay, now you're going to have that ability to go, let's use the Ionic components. There's nothing going to be stopping us once this comes out. I mentioned earlier they've got to make money. That's where Ionic Pro comes in. These are services that they charge for that you don't have to use, but they hope that it adds enough value that it will save you enough time and money that you want to pay for the services. Stuff like deploy. It kind of sucks to actually go through the App Store for every little thing. Imagine you misspelled a word somewhere, and now you've got to go through the whole App Store process and wait for a week or two for some misspelled word. With deploy, as long as you don't update the binary, which means I didn't add a new Cordova plugin in there, I'm just updating HTML, JavaScript, CSS, you can deploy your code up to the Ionic servers, and the next time somebody opens the app, it will pop up something that says, hey, there's an update to the app. Do you want to install it? And it will download all of that code live for you without going through the App Store. They have the ability to do cloud builds. So if you don't have a Mac, you've got to have some place in order to build the Mac components they offer in the cloud builds. They have an error reporting section. They have a drag and drop prototyping environment. So if you've got people that aren't HTML savvy, and they just want to get a prototype up and running, you can drag all the components there. You can set up all the routing. Pretty cool little prototype, all web-based. You can find all these at ionicframework.com/products. So some resources for Ionic. Their docs are fantastic, as we mentioned earlier. The second link, the Ionic Worldwide, goes to their Slack channel for sign-up. There's some great blogs out there. At McGivery.com, Andrew actually has been collecting all kinds of different resources and sticking them on one spot. Hopefully, at some point in time, he'll finally stop putting the number of actual posts in his title, because it's not 15. Last time I looked, he was at over 60. And I know in the Ionic 1 space, he was well over 200. Josh, second link up here, I don't know how he manages to put out so many tutorials. He puts out between 3 to 5 tutorials a week. And good tutorials, advanced tutorials. And then Simon has devdactic.com. He's got tons of tutorials up there. He's actually got a whole video course set up there. So lots of good free resources. There's also 3 books out. Josh had the first book that came out during the beta stage, and he's been keeping it up to date. Now, unlike a lot of books, that whatever version was there when he published, that's it. He self-published it, and he's been keeping it up to date with every version, making the changes. Simon at Devdactic also has a book. O'Reilly recently released a book as well. So in closing, if you can make a great web page, as you've seen, you can make a great app. It's time now to go create your mobile app. You can get these slides at slideshare.net/digitaldrummerj. My website's digitaldrummerj.me. And you can follow me on Twitter, YouTube, and Twitch at digitaldrummerj. Thank you.